On one hand, you have light, a massless particle unaffected by gravity that can never slow down. On the other, you have a black hole, a celestial body which ensnares anything unfortunate enough to cross its surface, created by massive amounts of gravitational force. So, what happens when two objects with such contradictory absolutes collide? Let's find out. Any photon traveling through normal, unwarped space stays in a constant direction as long as there's no outside forces enacting on it. But what happens when space becomes warped? Well, as you can see, the photon's path begins to bend. The bend is only visible to the outside observer because a straight path is defined by space itself. The photon considers itself to be going straight. Warped space leads to a few unexpected consequences. As you know, the shortest distance between 2 points is a line. So, if we define the far left of each one-dimensional plane as point A, and the far right as point B, we can see that as the curve in space increases, the distance and therefore time it takes for a photon to reach point B increases, even though the speed of the photon is constant. If we take this a step further and curve space infinitely, we can see that the distance to get to point B becomes infinite as well. So even traveling at the speed of light, the photon will never reach point B. Now, how does warped space connect to black holes trapping light? It connects because attracting particles that have mass isn't gravity's only effect. Gravity also warps space. What you see now is a diagram of 3 stars of 3 different masses. As the mass of the stars increases, so does its warping effect on the surrounding space. This effect continues to scale up until it hits the point of no return. As massive stars above 10 solar masses begin to run out of fuel, the outward pressure generated by nuclear fission weakens. The weakening of the outward pressure results in the former star imploding, exploding, then finally collapsing into a point of infinite density. A stellar black hole is born. This black hole's gravitational pull is so strong that once you reach the surface, it curves space infinitely inwards, as seen on the screen. I earlier showed you how an infinite curve in space results in infinite distance to travel along. So once light passes the surface, it's not that the pull of gravity holds it in. It's that, to escape, it needs to traverse infinitely curved space. That, my friends, is how a black hole can trap light without ever exerting any direct force in it or decreasing its speed from 3 times 10 to the 8th meters per second. As always, thanks for watching.